Hi everyone, I'm Roshan. I'm the University Program Assistant Director here at Mausfeld, and we have Ontology here with us. Thank you so much for being a part of this event and offering to do this workshop. I want to introduce Edmond from Ontology, and they're going to be doing a workshop for us today. Thank you so much.
Hello everyone, this is Edmond from Ontology community. Today I'll share you how to develop one decentralized application on Ontology blockchain. So the topic of today is build your first DApp with Ontology blockchain. So first, in this, I'll introduce what is a decentralized application, what it is like, and what is Ontology blockchain, and some key feature of one decentralized app. If you want to build one DApp, what's the key feature? And there is some fundamental knowledge before you must know before you start building your DApp. And I'll show you how to build a DApp with Punica. One Ontology suite is for DApp development. It's very simple, just maybe 15 minutes to finish your first DApp. So first, what is DApp? DApp is a decentralized blockchain application. First is a decentralized application that is in current, mostly it's based on one blockchain. It can be one layer one, based on layer one blockchain, or some layer two blockchain are also okay, but it must be based on the blockchain, because the blockchain network is a peer-to-peer network, so it's a decentralized network. For the application, there is one core part that is run on blockchain, that is smart contract. The smart contract is on the blockchain, which is the core part or the core protocol of your application. It allows your application, your application can connect to the blockchain. It also has a front and back end, just like the following figure shows. It can have multiple front and back end, maybe developed by a different person, but they share same smart contract on the blockchain. So that is what one DApp the deployment of one DApp look like. And all these front end back end may be different, developed by different persons, so they are run independently. So we see all the application are decentralized by multi-party, and they share the same core protocol, that is smart contract. So there's some key feature of one DApp, which is also differentiated with some current centralized applications, such as website or anything. First, it's also the most important is it's a decentralized application. Then no one control this application. It run on the blockchain. So it's belong to all the developer of this DApp, and everyone can join the DApp development at any time, and it can leave this ecosystem anytime. The second, the DApp is not just an application. It's a protocol or one algorithm. So it's an open protocol to everyone. To everyone. The core part is the open protocol is in this smart contract. So everyone which can access to your blockchain, it's the layer one blockchain or layer two blockchain, they can participate to your DApp. That is to join your ecosystem. So this is also the most important difference with current centralized application. It's the core part is a protocol or algorithm. It's not just one application. The third is there is the incentive, because it's a decentralized application. That is, someone can join the DApp ecosystem, and someone can leave the DApp ecosystem. So there must some incentive building That mostly it's crypto tokens to reward the participant to make sure your DApp can run for a very long time, because the DApp is because it's no one control it, so it's controlled by the whole ecosystem. So you have to carefully design your incentive mechanism to make sure the DApp can run for a long time. Even some founder of the DApp may leave the ecosystem, some new one can join the ecosystem to continue this DApp. The fourth one is it's not based on one blockchain. It can be one layer 1 blockchain or layer 2 blockchain or some other blockchain, but it's a data or it's code that is which is implemented the DApp protocol is in the smart contract. That is, it's shared by everyone in the ecosystem. So the code and data are stored in blockchain. It's not owned by anyone. It's shared in the whole DApp ecosystem. So next, we have got what is a DApp look like, and the next we how to develop one DApp. There is just four basic steps you have to do. First, you should know your project. What do you want to build? You have to design your DApp, design your goal, design your incentive mechanism, design your protocol, design your algorithm. Then next, you should choose one platform, one blockchain platform or framework to set up your project. Then the third step is coding your smart contract, coding your frontend, coding your backend. Then you have all DApp run on the blockchain. Then the final step is after you finish your coding, you need your test. Maybe you deploy on your testnet. Deploy on the testnet. Make sure everyone can join. Your ecosystem has been started when you are starting your test or deploy on testnet. Then finally, it's all done. You can deploy on mainnet, the blockchain mainnet to start. That is, in the design, there is some model you have to consider. One is governance model. That is how to manage your ecosystem and how maybe how to upgrade for the future. And you have to consider the token economics, that your incentive mechanism. After design, you start the engineering. There is a smart contract, there is a governance contract, or maybe if you, it depends on your incentive design, maybe have some staking. And then after the engineering, engineering is done, you deploy your DApp on the blockchain network. Next, you should start building your ecosystem. Then maybe your DApp may become one infrastructure for other DApps. So the DApp may depend on some other DApp, like the most famous DApp ecosystem currently is the DeFi ecosystem. That has lots of DApps they cooperate together to build one DApp, DeFi ecosystem. So before we start coding, there is some fundamental knowledge we must know. Before that is how one DApp run on Ontology blockchain. There's some question. First is how Ontology blockchain run, and which part of DApp run on blockchain on Ontology blockchain. That is its core protocol or core algorithm that is in the smart contract. So smart contracts run on blockchain, and there is some front and back end are run not on blockchain as off chain, but it's run in decentralized. Then we should know how smart contract work, because of our core protocol or algorithm or the core data and code are in the smart contract. So we have to know how smart contract work. Then we have the core protocol in blockchain and some front and back end is not on blockchain. So how to interact with how the front end and back end interact with smart contracts on Ontology blockchain. So I have 4 questions to answer. So for how Ontology blockchain run, it's just similar like most current other blockchains, such as Ethereum or the EOS. It's similar. They first had one decentralized P2P network that has lots of nodes in the worldwide. There's a decentralized network. For each node in the network, they are same. They contains all the world states and the smart contracts. For the people, if you want to use Ontology blockchain, you send your message to any node, and the message will be broadcast to all nodes. So that makes sure your is a message, or we call it a transaction. So you send one blockchain transaction to the blockchain network, to Ontology network. The node will relay your transaction to all nodes. And there is one consensus algorithm. Will pack all the pending transactions to blocks. Blocks are then relayed in the network and processed and verified by all nodes. Then for each node will check the consensus block and process and execute the transaction with and invoke the smart contracts and update the world state. That's basically how blockchain works, or how Ontology blockchain works. The next question is how smart contract work, because for the DApp, the most important part is the smart contract. So we have to know what smart contract work. For smart contract, it's invoked by transaction, or we say it message. For each transaction, there is some important data in the transaction. One is the address. The address is the address of the smart contract, which smart contract you want to invoke, and there's some input arguments. So this transaction contains contract address and input arguments. Then the transaction will be packed in a block. When the node in peer-to-peer network executes this process the block and process the transaction in the block, it will first when it processes your transaction, it first gets your pass the transaction, gets the contract address. Find there is for each smart contract there is some code, there's some internal storage with for this smart contract, and all this information are maintained by every node. So every node has this code or smart contract and have storage data for this smart contract. It will load the code and storage, and with your argument, put all this in a virtual machine, then the smart contract virtual machine, and process just like any CPU, load the code from disk, and load the data from database, and do the process, and get some output will be updated to the storage. So every smart contract has its own storage space. So the world state from sigma t to change to a new state, and storage state and its data of the smart contract will be updated. So this is how the transaction, how the smart contract work, or how user can invoke the smart contracts. You send the transaction to the network. Transactions are relayed in the network and packed in some block. When node process that block, will first get your contract address, get your input arguments, and load code to the virtual machine, and load previous state to the virtual machine. The virtual machine will do the processing, do the computation, and get the updated state to store back to the storage of that smart contract. That is how smart contract works. By the way, there is one different thing with current CPU is for each transaction on transaction processing on blockchain, it requires some gas. So you have to provide some gas to when you send the transaction. So in the transaction, you have to give the gas supply when the washing machine runs, the gas is consumed, and there may be some gas. The left gas will be refunded to your account. So that is the more complex your smart contract, the more gas will be consumed. So like any car, when you drive the car, it consumes some gas. The longer you drive the car, it consumes more gas. Yeah. So next question is how the front and the backend interact with smart contract on blockchain. Because we have said for each DApp there is a core protocol or algorithm that are in the smart contract. There are also some front and backend which can use by the user. Because the user cannot just send this transaction. It uses your website application or the phone application to invoke the to build the transaction and invoke the smart contract on blockchain. So here is the user must have the one has one account. Its account usually is a private key in blockchain. So the application can just send send the transaction to invoke the smart contract on blockchain. This transaction must follow because for each smart contract there is one binary interface. We usually call it ABI, application binary interface. So it has to pack its input arguments with this interface. Usually this function provided by SDK. For each blockchain, there is some SDK for different programming language. For Ontology blockchain, there is TypeScript, JavaScript, SDK, Python SDK, Java SDK, Golang SDK, and some other SDK. And so how to interact with smart contract? You follow the smart contract API, build your transaction, and send the transaction to blockchain network. Then all other are processed by the blockchain network. So that is how front and backend interact with smart contract on blockchain. We'll show how to do it. We'll show some code how to do it later. So that's all you need. You need to develop with that fundamental knowledge you need to know before you develop with Ontology. So next we start to develop one DApp on Ontology. There is some smart contract because Ontology supports multiple virtual machine that is support multiple type of smart contracts. If your smart contract is a lightweight smart contract, you can use Python. It's run on it's based on the new VM virtual machine. This virtual machine is supported by New and Ontology. If your smart contract is quite complex, then we suggest you use the Watson virtual machine. It has to programmed by C++ or Rust programming language. This virtual machine are also supported by EOS, Ontology, Polkadot, and will also be supported in Ethereum 2.0. So, but in our demo today, we use Python because we just developed some simple smart contract. There's a lot of tools for you if you like to develop with Ontology. There's some there's one DApp development framework that is Pyonaka. We will show how to develop with Pyonaka today. And there is some online IDE, the SmartX for you online smart contract programming. There are also Chrome plugin. It's one wallet. It's very convenient if you use to develop test your smart contract. There are some SDK. There is Java SDK, TypeScript SDK, Python SDK, lots of SDK for Ontology. So you for in your backend or frontend, you can use TypeScript, Java or Python or some other programming language. Both are supported. So next we will start the demo. Well, in the demo we'll use following tools. First is Pyonaka. It's an Ontology DApp development framework. It's very convenient for us to develop the DApp with Pyonaka. And SmartX, we test and coding our smart contract with SmartX. Channel wallet is to it's a Chrome plugin wallet to send transaction, to sign transactions, and explore the blockchain Explorer to track the blockchain activity. We can check what's the current state of our transaction. So there's just a few steps. First, you set up a project with Punaka. Then you coding smart contract with SmartX. Then you coding in SmartX, and you coding your front and back end with your any language you like. Then you do the deployment and test. So let's have a try now. First, we set up project with Punaka. If you don't know Punaka, you can follow the follow link to show what is Punaka is. This is Punaka is the app development framework. First, you need to install the Punaka. It's very simple. It's based on the Python. So you just pip install Punaka to install the Punaka. In our system, I have installed Punaka. So we just skip this step. After you have Punaka, the Punaka has some lots of functions. For us, we just use unbox. Just in Punaka, there is lots of boxes. I show it here. This is Punaka website, and you see there's a lot of box. You can just unbox and it get one DApp, and you based on this template to build your DApp. In our demo, we show how to use this box. It's interplanetary album. So you can it's based on blockchain, Ontology blockchain and IPFS. So that you upload your photo to IPFS, and you share your photo with your friends on Ontology blockchain. That is the basic function of our demo. Okay. So next we finish the first step. Open your command line. So you have Punaka. You can see there is a lot of function. We just unbox the interplanetary album. Unbox this. Maybe it's a network issue. Okay, so maybe it's a network. I have some backup. So when you the unbox actually the git clone git clone the project from it's just in this it's similar like git clone from this GitHub. So I'll just clone it. Usually we use the unbox command. You don't need to know the GitHub URL. Just do the unbox. So during the unbox, the network may be some slow. So I'll just continue on the next. I'll just use some my backup. I have some we just use this folder because I have some backup here. If you clone it, you just you see there is some files, just like in the GitHub. There is a contract, image, wallet, test, source code. There's punaka.json. The config file. First, because we have finished, if you want to develop your own your DApp, first you need to design your DApp. But in our demo, we have finished the design. We want to build one album based on the blockchain. That is, the photo will be uploaded to IPFS, and we share the photo on Ontology blockchain. So we check the smart contracts. There is one smart contract which is using Python programming language. We check it. Yeah, this is the smart contract. Then first, the next step, actually, we should continue code your smart contract with SmartX. So we just use the SmartX to build our to code our smart contract. But before you log in SmartX, you need some wallet file. Personally, I like to use the Ontology command line to create some wallet file. Okay, so I just use Ontology. You can get Ontology from Ontology GitHub. It's in right here. Yeah, it's in this GitHub. ONTIO Ontology. You can download it from download the binary from here. If you like Linux or Mac OS, you download this. So I just create one wallet with Ontology command line. Input your password. Okay, you see it's public key. I create here in this path, so it's in the same folder of my DF. The next, I'll log in SmartX with this wallet. SmartX, okay, browse this file. And your password, lock it. And you also, because for any development on the blockchain, you need some gas. So I need to apply some test gas. I'll get my wallet address. This is my address. Apply some gas. The application will be quite soon. So next step, I also use this Cyano wallet. Oh, I need to import my wallet. I just created this wallet. Yeah, we see I have 100 gas and 50 testnet, just add testnet. You can see this wallet on the testnet. It's not on mainnet, so just for testing. So next, I'll start the smart contract coding. First, I need to create a new project with Python. This with Edmond album. Okay. So it's totally empty. So we start coding the smart contract, but currently we just copy the template from here. Copy the code from the Pionaka. This is one smart contract. Well, we can see there is it's based on Python. It's in, the smart contract also has one entry point for just like any programming language, any program. Is the entry point is main function. It has four functions. One is put one item, then it put one item to in the blockchain, and the get an item list. Suppose I put some items that I can get, which has been in the in my smart contract. Then delete one item. I can delete one and clear everything. So I'll just for sure I need to copy. There's one thing I need to mention that because there's a lot of people using the blockchain. There is especially when you copy the smart contract from website. This smart contract maybe has been deployed on the testnet. So you have to make sure your smart contract is unique. Otherwise, the deployment will be failed. So I copied my address here to make sure this smart contract is unique. There is for example, if we check this function, put one item to the blockchain, there's some arguments, the ONT ID and encrypted IPFS hash. That is when I upload the IPFS path to the smart contract, I make it encrypted. So make sure that because the blockchain data is open to everyone, I don't want to anyone to access my photo without my permission. So I can share this photo with someone I know, but I don't want to share with everyone. So there is some other parameters. The function, how we put one in smart contract, we first build one key. The storage is based on the key value state. So we build one key and then put the key and data into the smart contract that will be stored on blockchain. So for smart contract, we first step is compile the smart contract. We see there's some bytecode. This bytecode will be processed by virtual machine. There's also ABI, the application binary interface. There's 4 functions: put one item, get and delete and clear. All these functions will be used by our frontend and backend. So next step is to deploy it. The name is version, which is make it simple. Okay. We do the deploy. For deployment, you send one transaction to blockchain. So into signed by this smart contract deploy operation. So you need to sign by the Ciano wallet. Input your wallet password. Confirm. Okay. So we see in SmartX, we can see the login. There is the deployment has been finished, and the contract, the contract hash or the contract address have been generated for us. We should copy this. The next step, we have just finished our smart contract development. The next, we should test this smart contract. So we can put one item. We just use this address because this is my address. We just invoke this function in the testnet. So all others are string. So I can test with X because it's just testing. So I can just make some run. For each transaction you want to send to blockchain, you need to sign it with your wallet. I need to pay some gas. Yeah, I can see there is some gas paid by this account. So we can see there's transaction here. We can check it on the Ciano on blockchain Explorer. First, we need to change to the testnet. Okay, so we search this on the testnet. It's blockchain hash. So it's just invoked by me. You can see the events here. It's a success. So I know I just invoke this function on the blockchain. The smart contract has been deployed on the testnet blockchain, and I just put this function, put this information in the smart contract. So next I have to check if this information has been in the smart contract. Okay, because the get item is just a read operation. It's just a query, so it don't need to send this transaction to blockchain network. You just pre-run it. For the pre-run, it don't need to consume any gas. So just pre-run to get it. Yeah, I can get this answer. What this answer is, you need to decode it because it's in the hex format. We can see the answer is these 4 strings. I need to decode it. What it is string X, which is exactly what I just did. Okay, so we have finished the 2 functions. One is put one item, get item. Then I can check the delete item. So the ONT ID is I just use some wallet address. This format must be correct. Otherwise, the smart contract will cannot pass it. So this is string. The hash will be X. For this part, we have to use because the delete operation is not a query. It's a transaction. It's will make some change on the storage, on the smart contract storage. So you have to run it, not just pre-run. For pre-run, it just query the storage. That's okay. So next, I need to check the sign it again, sign the transaction. Okay. So next, you can see there is let's see. Some response. Maybe I just use different. A too short public key. Okay. For the delete item is ONT ID check with address is correct. Run it again. I can for the pre-run to check if there is something wrong with my pub key. Oh, it's too short pub key. Maybe the address. So anyway, there is one. You should be able. There's something wrong with the smart contract, maybe, but you can debug it later. For the smart contract development, you should make sure to test all your functions before you finish your smart contract development. Then after the smart contract development, the next step is for the front end and back end. So you need to use the Punica. It's very simple. It has one template for you already. We check the Punica. It has source code here already. You can make some change if you want to change the when you develop your function. There is one template for you as a start for you to develop your own DApp. For our side, it's just you need to for Punica it's Python based. First, we need to go to the virtual env. Then we need to pip install requirements. So all the requirements are installed. The next step, because we are using the IPFS to store our photo, so we create one photo. We start our IPFS. For our testing, I just using IPFS in locally. So I export IPFS. Pass is then I start IPFS. Right here, I just changed my local port to this port. Yep. IPFS init. Then start the IPFS. Okay, we have started the IPFS, and we can start to check how our DApp will be look like. Python. Oh shit! Before this, I need to make some configuration. The IPFS port is 1990. The smart contract address is we just deployed on here in the SmartX. Yeah, this is our smart contracts. Then we start because we have to put your smart contract address here. Otherwise, your DApp don't know invoke which smart contracts. So you have to configure your network. In our case, it's a test network. It's paris.ont.io, and you have your smart contract has been deployed. This is address, so you have to update your configuration. Then we start yeah, so we can check it if it works. Oh, local. Yeah, this is our default account. This account is also in our wallet address. If you like to use your default wallet or you create your own wallet, both are okay. For the default wallet, the wallet is in GitHub, so its password is just password. You can log in. You can see there is a album here, but it's no picture. You can upload some picture here. I can find some photo. Maybe here. And upload to IPFS. To upload the photo, it will send the transaction to blockchain, so you have to sign it. The password is password. Yeah, you can see there the transaction hash. You can check it in Explore. It's a testnet transaction. You see, it's just send right now. So you can check this. Yeah, we just load our photo here. You can share with your friends. That is the very simple DApp. It's based on blockchain. You can check your smart contract actually. We just show your smart. Our smart contract address is here. So we check our smart contract in the Explore. Yeah, it's a smart contract. Its name is Edmond's album. There is some transactions, just two. Yeah. So basically, this is how we just finish one DApp, which is very simple. You can share your album share your photo with everyone. Yeah, I think we just finished the one DApp. The demo is very simple. Just maybe 10 minutes, less than 20 minutes. But I have something. If you like to learn how to code in the app, there is something you can do to improve this this demo. That is this function. This delete. We have the delete function. This delete function not work right now. I wish you can implement it. You can do it for us. We have one bounty for it. It's like in which bounty? Oh, you can check it on bounty. Yeah, this one. That is the support the delete photo from album. That is if you like do it, you can help fix this application, and you can apply for the bounty. There is some 150 ONG for you to get. Okay, if you develop your own DApp and you would like to share with us, you can also upload your DApp as a P9 box, because currently we have 6 boxes here, which shared by our community. If you like to share your box for any DApp, can be packed in one box. You like to share your box, you can apply for this bounty. It's about $200. Okay, I think that's all for our sharing today. Okay.
Okay, great. Thank you for the ontology workshop. That was very cool. Thank you.
Okay, thank you.